So great to be here today. I'm going to talk about building information management, but I'm not going to talk about Revit or any of kind of the design software. I'm about 15 years away from having to do any drafting or anything that resembles it myself. But what I am going to talk about is the application of data sets for achieving sustainability outcomes. In some of the work that I'm doing, both in the on the volunteer side of my life, and then also in my day job here at Concert Properties. So, in terms of the overview of what we're going to talk about making use of big data sets. So, what a time to be alive if you like to solve problems and you're into data. There's never been a better time, I think, to be around than right now. I'll talk a little bit about how these data sets and the right application or right level of data is critical to making strategic decisions. And then kind of building, I really liked what Oliver had to say about that golden thread that went through the design and construction phase. But maybe I'll talk about maybe weaving a path from strategic goal setting right down, drilling into how does that manifest itself into on the ground projects using data to guide those decisions. And specifically in the context of our environmental social governance framework at Concert Properties. And then I'll talk a little bit about what's next for us. So like the kind of the emerging technology tools that are getting adopted today at Concert Properties. So getting the data out there. So I mentioned I have a little bit of a side gig where I volunteer with a small nonprofit called the Open Green Building Society. It also has a for-profit arm that is an affiliated subsidiary called Open Technologies. In the last 6 months, we've just launched our first 2 ready-for-market products. And both of them are platforms that help to visualize large data sets aimed at decision makers, both in government and the private sector, and basically just making better use of all the data that we already have out there in the construction industry. So the first one is Shift, and the other one is Grid. So what is Shift? Shift was a collaboration that we undertook with the Vancouver Economic Commission. Helen alluded that I have a sordid past as a policy wonk. I'm a recovering bureaucrat. I have good days and bad days. Sometimes I end up in council chambers. I don't know how I got there. But this was a project that we worked on with Vancouver Economic Commission. And in my life as a policy wonk, a lot of the work I did on high performance green building codes was always trying to justify the incremental performance weighed against the incremental capital costs, right? And this false narrative that we've woven in that higher performance buildings have to be less affordable. But what we never did when we were looking at the opportunity of adopting a higher performance building code, well, what was the economic potential outcomes of adopting a high performance building code? So a lot of research was done on the back end of this project by Vancouver Economic Commission. And what they looked at was the BC Energy Step Code and the adoption of it and what it would mean for our local economy. And so, and I guess just at a high level, for those of you who aren't super familiar with building codes and the BC Energy Step Code, specifically is it moved us from a code framework which was very mechanically based and looking at the efficiency of a plant and that really governing the outcome of how efficient or sustainable you were. And the BC Energy Step Code is kind of more of a passive house based framework, which really looks at the building envelope and fabric and design. And the two differences in terms of how investments are made on both those pieces of equipment are a lot of the mechanical systems are built in places like China, Korea, Japan, Germany, places that aren't here and local. But when we think about the envelopes of our buildings, the windows, often those are made by local companies here based in Metro Vancouver, or the wall panel systems. We again have modular wall panel systems that are growing up right here locally in British Columbia, as close as Pemberton here. And by switching from this high performance building code, or to this high performance building code rather, that looked at a more envelope-based approach, we could show that there was about a $3.3 billion opportunity just with the current rollout of the BC Energy Step Code. And you could play with different scenarios within this tool to look at what if your local government adopted a higher step of the BC Energy Step Code? What are the potential job creation opportunities? What are the potential sales opportunities for high performance building technology? So this is very useful. It's a tool that helps external investment into British Columbia. So trade missions are using it in China right now to show, oh, look at the potential opportunity here in our small province. But by leading the way on green building policy implementation, we are creating new opportunities for investment here in British Columbia. So again, just taking the existing data sets that are out there, doing some preliminary modeling, and then showing allowing people to play with the data in a way that they can understand and matches their thought process. The second one is probably a bit more conventional. It's called Grid. And what this is it's a data visualization tool that interfaces directly with the federal government's Energy Star Portfolio Manager building energy benchmarking system. And what it allows us to do is take that information where buildings are entering their building attribute data and their energy use data into Portfolio Manager, and then place that data in space. And the first application of this was the Canada Green Building Council's Disclosure Challenge, which allowed us, a couple of companies, of which Concert Properties is one of them, to say, okay, well, we're gonna pull back the curtain and show to the public how actually our buildings are performing. So Quadreal and TrioVest were the other two companies that were first out of the gates in terms of volunteering for this initiative. And the idea behind it is that we can't actually transform ourselves as an industry if we're actually always hiding our problems, right? And even as a builder such as us or as Quadreal, who've adopted the most aggressive sustainability targets of any company in Canada, we're signed on to COP21 style targets of absolute caps of 80% reductions by 2050. But we have problem buildings too. But we also have some success stories. And until we get serious as an industry and start being transparent about our successes and failures and catch up actually to the rest of the world that it's actually got data disclosure and transparency. The UK being a great example, Europe being another one, Australia has actually done a lot of work in this area. We can't actually really meaningfully know where to start. So this technology is fairly simple, and it's designed to help cities who want to launch their own building energy benchmarking programs. And then once they have those programs, give them the tools to actually start to dive into the data and see where the problems are in their own jurisdictions. Do I have one more? Yeah. So the idea, the great promise of these building energy benchmarking and disclosure initiatives is to not only sort of pull back the veil and show where we might have problems, but it's also to aid local governments or authorities in terms of not making more policy, but better policy, right? How do we actually strategically target the worst performers in our building stock, and not just every building in our building stock, right? The problem with blanket regulations is, or even blanket incentive programs, it's actually worse on incentive programs, is where you end up giving money to people who probably already would have been taking advantage of seeking out higher performance buildings and money saving opportunities, right? Whereas we can now structure our incentives to go at the bottom 20%, where probably 50% of the total savings could possibly be achieved. So we just launched another program or collaboration on the disclosure initiative with the largest cities in Metro Vancouver. Soon to come on board, hopefully, is City of New West, City of North Vancouver, and City of Richmond. And the goal is to get 1,000 buildings into Building Energy Benchmark BC by the end of this year. And we have a great start. We have about 250 buildings already in the first month. So watch this space closely. So that's, and I would just also note that open technologies, the idea behind it is that we try to create these tools and platforms in an open source format so that it's easy to adopt for local governments. And I know that local governments can kind of be paralyzed by procurement sometimes. The idea to try to give them tools out there in a way that is free and open is the goal in this case. So that's kind of the big meta look of sort of how big, I guess, data can help us show both the opportunity and what's required to move forward in the built environment here locally. But now I want to take the owner's perspective and talk about what we're doing at Concert Properties. So for those of you who may not be familiar with Concert Properties is a union-owned pension fund. So we're owned by 17 very small trade unions, both locally here in BC and Alberta. When I say very small, some of our member unions are only about 200 people. And we, through making real estate investments, support the retirement income of about 200,000 Canadians. We were started about 30 years ago with the notion that we would, in partnership with government, build affordable rental housing close to transit and only use union trades to support income. So you could imagine the mission of Concert Properties was as relevant back in 1989 as it is in 2019. And recently we've kind of gone through a reimagination of what it means to be a good company, and within that tried to reimagine ourselves as a leader in both environmental and social sustainability. So we launched our sustainability framework just in September of this year. It has 15 different sustainability principles that span both social, environmental, and economic. It sets out our targets to achieve carbon neutral new construction by 2026, ahead of both federal and provincial mandates. We're trying to achieve an 80% reduction by 2050 across our portfolio based on 2017 emissions. And I'll talk a little bit about why that's the most audacious / scariest target we've ever adopted. But in addition to the kind of those hard environmental metrics, we've also tried to tackle some fuzzier social metrics as well too. So things like targets to combat urban isolation and loneliness. The fact that we're building these high density mixed use communities that we thought would make everybody happier, or maybe actually making everybody more miserable. A commitment to build climate resilient housing. So how do we make sure that the products that we're building, if they're going to be 50-year retirement investment vehicles, how are they going to be built for the climate 50 years from now? And then how do we look at integrating healthy and low carbon materials into our supply chain? And I'm happy to say that in the 3 or 4 months it's been out there, it's been downloaded over 10,000 times online. So I didn't even think anybody in our own company would read it, to be honest. So I'm pretty happy. Not to say that anybody in our own company has, but I think we're doing a lot of work to help our competition out in terms of developing new sustainability frameworks. So what do deep emissions reductions look like for a company such as ours? So, everyone talks about an 80 by 50 framework, and it sounds rather academic, but to put it into context, it's kind of scary for a company like ours, where over that same time frame, if you imagine we've been in business since 1989, 30 years till now, the company has grown, roughly 5 times. We want to keep or accelerate that growth. So we want to grow between 5 and 6 times in terms of our current total square footage and valuation, but we want to reduce our emissions by 80% over that time. So that means we have to do a lot of sprinting just to stand still and try to find some real transformational leaps forward in terms of actual meeting real emissions reductions. So when you model that out, it means that we have to be reducing in absolute terms 3.8% of our portfolio emissions every year, no questions asked. And that's what this sort of looks like. This red line is our business as usual out to 2030. The blue line is our planned emissions reductions within our sustainability framework. And what this told us is that while we can't get there without starting to build zero carbon buildings, either by 2026 at the absolute latest, but hopefully earlier. We are hoping to deliver earlier on that. But we actually have to start decarbonizing our building stock. So this isn't just 15, 20% energy efficiency reductions. This is actually how do we get the fossil fuels out of our buildings and just stop burning stuff in our buildings. And we have to do about 3 to 4 of those projects per year, every year, in order to meet these targets as well too. So this was useful for us in terms of just being able to scope out a problem, right? Anybody can adopt a target, but in terms of being able to put it into concrete terms and say to our board, my CEO, my boss, to say this is what we actually are in for. These are the costs of it. This is I guess kind of what sustainability 3.0 looks like, right? What's the data? What does it cost? And how are we going to get there over time? So to drill even deeper on this, this compelled us to look at where actually our emissions coming from. So, our portfolio, it's quite interesting to look at. We're about 70% by square footage, actually commercial industrial. We own a lot of big sheds and light industrial facilities. But when we look at actually where our emissions are coming from, it's actually from our residential portfolios. So we're active in BC, Alberta, and Ontario. We have about 15 residential assets here in British Columbia, about 11 residential assets in Ontario. They're all quite big buildings. We're talking about 350,000 square feet or thereabouts. But you can see that's where 67% of our emissions comes from. The other 2 big portions come from our BC office portfolio, just because it's quite large. But then unsurprisingly, Alberta office, which is actually only 3 buildings, is 14% of our emissions portfolio. It just shows you what a dirty power grid will do for you in terms of your emissions portfolio. So in terms of looking at where we need to focus, 91% of our emissions come in 3 asset classes in 3 provinces. So really allowed us to start to put together a strategic plan of where we're going to get started. So I talked about building energy benchmarking and the value of it. And when we benchmark our buildings, we typically take in roughly about 80 different points of data. And we can look at all sorts of different unique data points like, what's our site energy, what's our source energy, what's our emissions per square meter, what's our operating conditions of any different building. But I find that when you're having strategic discussions and you're trying just to plan to spend money, sometimes the simplest graphs and the least amount of information that you can communicate to decision makers is actually the best. So working with SES Consulting, we put together a couple of these very simple graphs to start to frame our conversation about where we need to make investments. So these are a portion of our residential assets in Ontario. What you can see is the average benchmark EUI for a new project in Ontario. And you can see the electricity and gas consumption of these buildings. So this was sort of a wake up aha moment for us at Concert Properties. We like to think of ourselves as sort of a best in class manager and owner. Anytime we were replacing equipment within a building, it was always Energy Star. Anytime we were looking at doing renovations, we had been through a couple of energy audits where we were always doing anything that had a 3-year payback or less. And what we found was that all of our assets were performing worse than the average EUI benchmark of buildings built in the last 5 years. So, there's a lot of tough conversations and reflection about why is this? How could this be? The data's got to be wrong. We reran the numbers 3 or 4 times and found the data was right, but we had never actually done this before as an asset manager. We, believe it or not, whenever we're setting budgets, we always just looked at what we spent on energy last year and replicated that this year. We always looked at savings in terms of cost. We never looked at savings in terms of greenhouse gases. So just reframing the data that we already had helped us make better decisions. So we also did the same thing for British Columbia. And what you can see in British Columbia is that actually our electricity usage, you'd expect most residential assets to have a pretty even split of 50-50 in terms of electricity to natural gas use. That's just the general way it falls out in the multifamily sector. But what you can see is we've actually done a pretty good job in terms of lowering our electricity use. And that's probably because there's been some very good incentive programs on the electricity side. here in British Columbia, but we are using way more natural gas than we probably should be in any of these assets. So this allowed us to create a hit list of our worst offenders, and what really floated up was our project 600 Drake here, which I'll talk a little bit more about, because it was probably about twice the average EUI benchmark of a residential building, and using far more natural gas than it should be as well too. So we dug deeper. This is where we targeted our GHG reduction retrofits. We reimagined our retrofit process and our auditing process through this as well too, because as I mentioned before, we've not only adopted carbon reduction targets, but also building resilience targets. So how are we going to adapt and retrofit these buildings to be more resilient to climate change while we're also making them lower carbon? And so what does that mean in British Columbia? Our biggest climate change risks, if you're not on the waterfront, are extreme heat events, which we're going to have more of. And by the way, more people die in extreme heat events than they do in extreme cold events. The mortality rates for vulnerable populations, the very young and the very old, are more sensitive to heat than they are to cold. And air quality. So for those of you who are local, you'll know in the last, not this summer, but the two preceding summers, Vancouver had some of the worst air quality in the world due to forest fires, right? So if you actually looked at the 5 worst, I don't have it in this slide deck, but I like to show from August 2018, the 5 worst places to be in the world for air quality was Seattle, Vancouver, and then a bunch of cities that you've never heard of in Kazakhstan and Iran, who are basically glorified oil refineries. So, so we have to start looking actually at air filtration within our buildings as well too, because we could probably expect more forest fires in this region as well too. So we also looked at emergency backup powers, which are critical to responding, where if we're going to have more inclement weather and storms and greater volatility, we have to look at not only how do we evacuate people with emergency backup power, but how do we make our buildings survivable for 72 hours if power does go out. So now that more than half of our population lives in multifamily buildings, not everyone can go home to their parents in the suburbs if they're without power in February for 3 days, right? So, and that was actually found to be a huge resiliency issue in Christchurch, for example, where people were left without power for weeks. So we undertook all of this review of 600 Drake for both resiliency measures and for low carbon measures, came up with this solution here. It turns out the big problem at 600 Drake was we were using sort of an Ontario style 2-pipe fan coil unit, which was natural gas based, kind of unique in this environment for a rental property. It was unmetered, so the residents' heating was just coming out of their rental bills. And what we found were these little mini split heat pump units that come from an Italian manufacturer. And the benefit of these units is that they use electricity, which is 92% carbon free in this province. They provide air filtration, so you can fit a MERV 13 filter in that, which is kind of a medical facility grade filter. And they can provide both heating and cooling. So the benefit of this project was kind of like for you Scrabble players out there was a triple award score, right? In that we were able to address our climate resilience goals by adding cooling and air filtration. From a sustainability perspective, we were able to cut carbon by about 50%. And then additionally, we were from a market transformation and behavior perspective, we were also able to shift the costs directly to the unit. So that somebody was actually starting to pay for their heat, and we have good research out there to show that when somebody actually gets the bill for their heating, that could have about a 20% impact or a reduction on consumption. So great news story for us. We're just in the testing phase of this. We've installed this in 4 units in 600 Drake. They're doing well throughout the heating season. So if everything continues to go well through to March here, we're going to do the whole project this August. So, and this is probably a project that wouldn't have come to light had we not taken a critical look at the data within our portfolio. So where I'll go is that's our existing portfolio. We'll take a minute to talk about the tools we're using for our new buildings. So one of the things that we absolutely have to do on every new project, and we have committed to do as an organization, is parametric energy and carbon modeling at the design phase. 3 minutes. I'll wrap up. This is actually, again, another product that one of the ones that first brought me to open technologies. But this idea of doing an energy model, a single energy model based on our gut instincts of what a good design will be, and then running that once, asking about a bunch of questions, maybe running it again, and having probably a 6-month gap in terms of how that design is progressing between those energy modeling runs, is really not giving us the best outcomes, right? And it's expensive. So this new idea of doing, instead of 1 or 2 energy models, running 50,000 energy models of the same buildings, and then being able to evaluate all of these options using data visualization technology, and instead of doing the modeling in real time, just accessing it through a database, which is uses much less computing power, is much more nimble and agile, and then be able to do that in a process where we have the entire design and ownership team there is builds so much more buy-in and saves so much more time in terms of forging a path forward on low carbon design. What it allows us to do is it allows us to do a backcasting search. So this particular tool, those of you who've maybe worked with Morrison Hershfield or EQ Building Performance out in Ontario, the last 3 vertical lines there are of course, the step code metrics. So you can sort by those, or you can sort by the other kind of big moves that you'll make on your building, whether it's window to wall ratio, window R value, or wall R value, your heat plant. And what this allows us to do is this sort of says, well, okay, these are the maximum targets we're going to hit here on the right-hand side, and then what are our options here on the left-hand side from a feasibility perspective. And what I can say is that this has greatly, enhanced our ability to cost projects at the outset, to make big moves early in terms of we're not trying to get a 70% glazed building down to 40% during design development and trying to figure out a new structural system, but it's also allowing us to kind of make those moves early and at zero cost. And there's, this is just the tip of the iceberg. I'm sure many of you who are doing in the design field right now are using parametric modeling now, even just for, modeling how different suites can be configured, doing thousands of different options on envelope design and configurations about how big your window panels should be and how they should be optimized. There's parametric modeling out there to do structural grids for tall timber as well too, which is really helping us optimize not only our space, but also minimizing waste. So I think parametric modeling as a tool is here to stay. And it's probably going to be one of the biggest things I think is going to revolutionize the design phase of what we're doing. And I think it's not just sort of like a nerdy tool in terms of the analysis it provides, but I think it can be used most powerfully in those collaborative design environments where we all have the information together and we can instantly see the ramification of our collective decisions. So I think it's not just a technology solution, but the way that it can transform our process and our design thinking, I think is the real power. So that is me. Thanks. Am I on time? Okay.